Hi everyone, Miss Afric here today, and we are going to get started on our probability chapter, which is actually chapter 12 in your book. In our first video, we're just going to do the basics, and the basics are the fundamental counting principle and permutations. So we're going to be talking about that today. You should be excited about probability. That's why I put this exclamation point here, because probability is one of the best parts of math, I think, because it applies to everything. You can pretty much come up with a problem that relates to any part of life, and you can test me on that in class. But for now, let's get started on these notes. If you did not print out the note sheet from Edmodo, then just make sure you pause the video every so often so that you can write down these problems, because there's no point in writing down the answers unless you have the problem there too. So make sure you pause the video. Example number 1. You're trying to decide what to wear on the first day of school. You've narrowed down your options. You've narrowed your options down, to 5 different shirts, 4 different pairs of pants, and 2 jackets. How many possible outfits do you have to choose from? So the likely way that you think of doing this is, okay, well, I have 5 different shirts. So let's say we have shirt 1, shirt 2, shirt 3, shirt 4, and shirt 5. All right, to figure out the total number of outfits, I just need to figure out how many options I have with each shirt. All right, so shirt 1, well, we could do pants 1. We could do pants 2. We could do pants 3. Or we could do pants 4. So right there I have 4 options. But then remember, I've got 2 jackets also. So each of these could be jacket 1 or jacket 2. Oops, jacket 1, jacket 2. And that's with each of these. So just to shorten it, I'm going to write J1, J2, and it's getting kind of squished in here. But you can see, right? Shirt 1, we could do shirt 1, pants 1, jacket 1. We could do shirt 1, pants 1, jacket 2. Shirt 1, pants 2, jacket 1. Shirt 1, pants 2, jacket 2. So there are a bunch of different possibilities, and if we count them, well, we have 1, 2, 3, 4, 5, 6, 7, 8. So this gives us 8 different outfits. And that's just with shirt 1. We have to repeat the same thing then with shirts 2, 3, 4, and 5. And each of them are going to end up, because we're breaking it up the same way, each of them are going to end up giving us 8 different outfits. So if we get 8 different outfits for each of our shirts, then add all those up together, and we're going to end up with 40 total outfits. And that would be the answer to that. So how many possible outfits do you have to choose from? 40. Now that process we did, that's called creating a tree diagram. And you could do it for any problem. You could create a tree problem for any problem. But as you can see with this one and with ones that have bigger numbers, it gets kind of tedious. You've got a lot you've got to write down. You have to keep track of everything. Sometimes you end up squishing things in like I did here. And you don't want to have to do that for every problem. So that's why we come up with the fundamental counting principle. So the fundamental counting principle says that if one event can occur in m ways, so just some number m, a second event can occur in n ways, and a third event can occur in p ways, then the number of ways that all 3 events can occur together is m times n times p. So to think of this applied to that problem we just did, well, I can wear how many shirts, how many pants, and how many jackets. And then once I figure out each number of ways, I just multiply them together. So how many shirts can I wear? Well, there are 5 different shirts. How many pants? There are 4 different pants. And how many jackets? There are 2 different jackets. So we do 5 times 4 times 2, and that would give us 40 total outfits. See how much faster that is? So this fundamental counting principle is really important. We're going to be using it a lot while we do counting and probability stuff. Let's try one more example. Example 2. It's been 2 weeks of school and you have already forgotten your locker combination. Everyone's locker combination has 3 numbers between 1 and 32. How many possible locker combinations are there? So using the fundamental counting principle, we know that there are three different numbers, right? Our first number, so number 1, our second number, and our third number. Well, it can be any number between 1 and 32, so that's 32 different possibilities. So there are 32 options for our first number to be. Likewise, there are 32 options for our second number to be, and once again, there are 32 options for our third number to be. So all we have to do is multiply all of those numbers together. We end up getting 32 times 32 times 32, which is going to equal 32,768, I believe. So that's 32,768 different locker combinations. Yeah, I don't think you're going to have much luck figuring out what it is. Now for example 2b, it says, suppose you remember that your combination didn't repeat any numbers. Then how many possible combinations would there be? So once again, we still want to break it up into our three possibilities. We have number 1 in our combination, number 2 in our combination, and number 3 in our combination. Well, our first number, there's still 32 different numbers it could be. All right? Our first number can be any of those 32 numbers. But then what this part tells us is that our combination didn't repeat any numbers. So that means that whatever number it is number 1 can't be number 2. So I have one less possible number for my second number in my combination, which means I have 31 possibilities. And then for my third number, well, it can't be number 1 and it can't be number 2, so that means I only have 30 options. And then we take those numbers and we multiply them together. And that's going to give us 29,760 combinations. Still a pretty big number, so I would still say it's going to be tough to figure out what that is. Alright, so those are a couple examples of the types of problems we're going to be seeing. Now let's talk about what we're going to be doing in probability. Two of the big things that we talk about before we really get into the probability part of it are permutations and combinations. Now, those are two very different things, and it's important to recognize the difference. A permutation is going to be an arrangement where order matters. Okay, so permutation is an arrangement where order matters. An example of this is, say, let's try that again. An example of this is perhaps the number of ways that 5 students can finish a race. Because it matters who comes in first, who comes in second, who comes in third, who comes in fourth, who comes in fifth, right? Those are all important. So order matters there. A combination, on the other side of things, is an arrangement where order doesn't matter. So an example of this could just be the number of ways to just pick 5 students from our class. Because it doesn't matter who I pick first, or who I pick second, or who I pick third, or who I pick fourth, or who I pick fifth. All that matters is that I need 5 students. Don't care what order, I just need 5 of them. So those are the two different kinds of counting methods that we're going to be using. Today, we're just going to focus on permutation. Today in this video and tomorrow during class. So in order to know permutations and combinations for that matter, you need to know what a factorial is. And some of you may have heard of this. A factorial in math notation, it just looks like an exclamation point. Oops. And the definition of it is if you have some number n and then factorial, that's how we say the exclamation point. So this is read as n factorial. That would be equal to n times n minus 1 times n minus 2 etc., all the way until you get down to 2 times 1. So an example of this is like 5 factorial, for example, is going to equal 5 times 4 times 3 times 2 times 1. Right? 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's what a factorial is. And there is a way to do it on your calculator. So I'm going to write that down right here. I'll show you in class if you're still confused, but you're going to press the math button. Then move your right arrow to the tab that says PRB, which stands for probability. And then it's number 4. Number 4 is the exclamation point, which stands for a factorial. So that calculator trick will really help you out when you get to those big numbers. Another really important fact with factorials is 0 factorial. You would think it equals 0, but it's actually defined to equal 1. So anytime you have 0 factorial, that's actually just 1. Alright, let's try one more example. So example 3. In the Winter Olympics, there are 12 men who compete in the finals for the men's halfpipe. True fact. In how many different ways can the snowboarders finish? Well, we've got 12 different places that they can finish in. So I'm going to make 12 different lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the person who finishes first, well, we have 12 different men, so there are 12 different people that can finish first. In second place, well, the person who finished in first place can't finish in second also. So we have one less person, that means we have 11. Third place, it's the same idea, right? Whoever finishes in first can't finish in third also. And whoever finishes in second can't finish in third. So we got 2 less people that we're worrying about. So then it's going to be 10 possibilities. And you keep going like this until you end up with that very last place where there's only one person left. So it'd have to be that person. And notice how when we multiply these all together, what we're actually just doing is 12 factorial. And you can go ahead on your calculator and figure out what 12 factorial is going to be. And you should end up getting a really big number, which is going to be exactly 479,001,600 different ways that the snowboarders can finish. That is a lot of different ways that they can finish. Big numbers we're dealing with. Alright, and then the second part, in how many ways can 3 men finish in first place, second place, or third place? Well, we've got first place, second place, or third place. So there are 12 different people that can finish in first place. And because the person who finishes in first place can't also finish in second place, there are only 11 possibilities for second place, and then 10 for third place. So we would go ahead and multiply these together. I'm going to multiply it over here on my simple calculator. 12 times 11 times 10, and that should give us 1,320 different ways that they can finish. Okay, well, I hope you've learned a lot. I hope this sparked your interest in probability. Get excited for class. We're going to be doing some fun stuff tomorrow. See ya.